China tests J-10C with PL-17 missile for long-range combat. A Chinese J-10C fighter jet was recently spotted carrying the PL-17, an active radar-guided beyond visual range air-to-air missile, a sight that has raised eyebrows among military analysts. The PL-17, known for its exceptional range and advanced radar guidance, is typically mounted on larger aircraft like the J-20, China's fifth-generation stealth fighter designed for long-range missions with a capacity for heavier munitions. However, the J-10C, a single-engine multi-role fighter primarily meant for shorter to medium-range operations, has a more limited payload capacity, making the pairing with the PL-17 somewhat unexpected. Traditionally, the J-10C serves in roles focused on air superiority and ground attack, not as a carrier for the longest-range missiles in China's inventory. This integration could signal Beijing's exploration into new tactical approaches, potentially extending the J-10C's role in aerial engagements far beyond its usual combat radius. If this adaptation proves successful, it could significantly enhance the fighter's capability to engage targets at distances previously unattainable, thereby increasing its strategic value. The technical challenges are apparent. The PL-17 requires sophisticated electronics and radar systems for long-range targeting, which the J-10C's modern AESA radar might not fully support to the extent needed for optimal performance. Successfully harnessing the PL-17 with the J-10C would be a notable technological leap, demonstrating the aircraft's capability to outperform expectations. Moreover, showcasing the J-10C with the PL-17 could be a strategic move by China to display its prowess in integrating advanced weaponry across diverse platforms, even those not originally intended for such roles. This move not only boosts the J-10C's combat profile but also sends a clear message to regional neighbors and powers like India, Japan, and the US about the evolving capabilities and flexibility of China's Air Force. In a hypothetical conflict scenario with Taiwan and the US, this combination could redefine air combat roles. The J-10C, equipped with PL-17s, could act as a long-range strike fighter, engaging enemy aircraft from beyond visual range, potentially before they could respond. This capability would be pivotal in the initial phase of the conflict, where securing air superiority could dictate the pace and outcome of subsequent engagements. Furthermore, the J-10C could block aerial routes, defend Allied forces, or even spearhead initial strikes against strategic targets, disrupting enemy command structures and infrastructure before they can react. The fighter could also play a role in electronic warfare, jamming radar and communication networks, thus hampering adversary coordination and operational effectiveness. In combined operations, the J-10C's new role could provide versatile support to naval and ground forces, offering a broad spectrum of attack options across different domains of warfare. This adaptability would not only enhance China's military effectiveness but also complicate defense strategies for potential adversaries. In essence, the combination of the J-10C and PL-17 could significantly alter the strategic landscape in East Asia, providing China with a distinct advantage in air combat scenarios, particularly in the critical early stages of any potential conflict. The PL-17, an advanced air-to-air missile from China, presents an array of significant technical challenges that its developers must overcome. This missile, which has been spotted on various Chinese fighter jets, is designed to operate at speeds that push the boundaries of what is currently possible in missile technology, potentially reaching or even surpassing Mach 6. Such high-speed performance requires a sophisticated aerodynamic design to maintain stability and maneuverability under extreme conditions. The propulsion system of the PL-17 is another area where innovation is critical. It must balance high thrust with fuel efficiency to achieve the missile's impressive range, rumored to exceed 300 kilometers. Advanced technologies like dual-mode or scramjet engines might be in play here, which adds layers of complexity to both design and implementation. Guidance and control systems are at the heart of the PL-17's capabilities. With an active radar seeker, the missile must be able to lock onto and track targets at long distances, even amidst electronic warfare attempts to jam or deceive it. This involves integrating state-of-the-art sensors with the missile's control algorithms, ensuring it can adapt to various countermeasures in real time. Additionally, the missile likely employs a data link for mid-course guidance, which must be robust against interception or jamming. Structural integrity is paramount, especially given the thermal loads at high speeds. The materials used in the PL-17's construction must endure extreme conditions without significant degradation, a challenge in both material science and engineering. The missile's size and weight also pose integration challenges on aircraft, particularly those with limited payload capacity. Resilience against electronic warfare is another crucial aspect. Modern combat scenarios often involve attempts to disrupt missile guidance with electronic countermeasures. The PL-17 needs to be designed with countermeasures, perhaps leveraging AI to dynamically